All right, this is objective 1.4. Evaluate a function for a given variable. This happened on either August 18th or August 19th. A function is like a machine that takes an input and gives an output. Normally that input is x, it goes into the function, and we get out a y. So this is x, and that's y. We also have to learn about function notation. This is a function. Normally you'd see a y here, but instead we have this right here. And the way we pronounce this is f of x. F of x. And this right here tells us that this function is named f. So that's the name of the function. This right here is the input in the function. So whatever's inside the parentheses gets put into the function. And this here is the actual function. So f of x equals 3x squared plus 1. That would be how you would say that. Well, evaluating a function, which is what we're learning, is basically a fancy way of saying plugging a number into a function. So evaluating means substituting a value into a function for a variable. So the variable in this function is x, and the input would be the value that we would substitute in for x. You're going to find a problem something like this. Example 1. Given f of x equals 6x plus 9 minus x, find f of 3. Our first step is to substitute the value in for each variable in that function. So this here says take function f, that's this function here, take whatever's inside these parentheses, in this case 3, and plug it into that function. So f of 3 equals 6 times, and normally we see an x here, but instead we're going to put the 3 plus 9 minus, and then again, instead of the x, we put the 3. Notice how I put each instance of the x in parentheses. That's important for later on when you want to keep track of negative signs. Then we're going to use PEMDAS to simplify. Remember that's parentheses, exponents, multiplication and division, and then addition and subtraction. So parentheses, while there are parentheses here, we don't need to simplify anything inside the parentheses, so we don't need to use the p. Exponents, there are no exponents. Multiplication and division, and we do both of those from left to right. So I see 6 times 3 is 18, plus 9 minus 3. Then addition and subtraction from left to right. 18 plus 9 is 27, minus 3, and that is 24. So f of 3 equals 24. In example number 2, we'll do the same thing. Given g of x equals 3 times x minus 8 plus 2, x squared, find g of 2. So again, we'll take 2, because it's inside the parentheses, and plug it into function g anytime we see an x. G of 2 equals 3 times 2 in parentheses minus 8 plus 2 in parentheses squared. Then use PEMDAS, parentheses. This time I do have parentheses. I have to simplify what's in here first. So I'll have a 3 on the outside, and then I know that on the inside, 2 minus 8 is negative 6 plus 2 squared. So I did my parentheses. Now exponents. 2 squared is 4, and we still have this part over here. Then multiplication and division. 3 times negative 6 is negative 18 plus 4. Then addition and subtraction. Negative 18 plus 4 is negative 14. So g of 2 equals negative 14. The next one says, example 3, if h of x equals x squared plus 3 over 2, what is h of negative 1? Again, take negative 1, plug it into function h. So h of negative 1 equals negative 1 squared. Notice I put the parentheses around the negative 1 plus 3 over 2. It's really important to put those parentheses around the negative 1 because this negative 1 squared and this negative 1 in parentheses squared are different. This means negative 1. So that's 1 squared with a negative sign in front of it. This is negative 1 squared. So negative 1 times negative 1 would equal positive 1 because two negatives equal a positive. So it's very important that you put your parentheses correctly. In this case, negative 1 in parentheses squared is positive 1 plus 3 over 2. Then, that was my exponent. Now I need to simplify the top and the bottom. So 1 plus 3 is 4 over 2, and 4 divided by 2 is 2. So h of negative 1 equals 2. Same process for example number 4. If f of p equals 4p plus 1, find f of 1/2. So f of 1/2 equals 4 times 1/2 plus 1. No parentheses, no exponents, straight to multiplication and division. 4 times 1/2, well, we put the 4 over the 1, and then we multiply straight across. So 4 over 2, and of course plus 1. 4 divided by 2 is 2, plus 1 is 3. F of 1/2 equals 3. For number 5, given k of x equals negative 3x squared plus 2x minus 3, find k of 2. So k of 2 equals negative 3 times 2 squared plus 2 times 2 minus 3. No parentheses, exponents first. Negative 3 times 4 plus 2 times 2 minus 3. That's probably the biggest mistake that anyone makes. You cannot multiply these first. You have to do the exponent first. Now we can do multiplication and division. So that's negative 12 plus 4 minus 3. Then the addition and subtraction. Negative 8 minus 3 equals negative 11. So k of 2 equals negative 11. And finally, example 6. Given f of x equals 6 minus x over x squared, find f of 3. So f of 3 equals 6 minus 3 over 3 squared. Parentheses first. When you're dealing with a fraction, remember that the top and the bottom are both like their own parentheses, so you have to simplify them before you can divide. 6 minus 3 is 3, and 3 squared is 9. That's 3 times itself. This is a fraction, so I can reduce it. Both 3 and 9 are divisible by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. So 1/3 is my answer. And that's it.